Good morning, guys. Today we're going to be talking about the periodic table and the elements that are on the periodic table and how to read the markings to determine what you need to know about those elements for using the periodic table. Okay, so your learning goal today would be able to identify numbers of each element on the periodic table and tell me why they are important. Okay, be able to explain why they are important. And the first thing that I want to do with you guys is I want to go over the markings of the elements on the periodic table because that's the most important part. If you don't know how to read that, you're going to not be able to understand it. So right now I need you to have your notebooks and your pencils, and you need to be able to write this down. Remember, the anchor charts are very important for understanding. They come from your state standard unpacking, okay, for North Carolina 8th grade science. So the periodic table, you have each element, and each element has a symbol, and each element has an atomic number, and each element has an atomic mass, okay? These two elements, I know for a fact you will need to know them and have them memorized. AU stands for gold. C obviously is for carbon, and we've talked about that one quite a bit. Okay, so what you need to know about the elements, the atomic number listed here, this is the number of protons in an element. Remember Monday we were talking about protons and neutrons and electrons, and we said protons and neutrons are found within the nucleus of an atom, and protons are positive, neutrons are neutral, and electrons are negative. So now we're going to dive a little deeper into understanding why they're important and how you know how many protons, electrons, and neutrons there are just by looking at the elements on the periodic table. The number of protons in an element is the atomic number, okay? And that's above the symbol for the element. The atomic mass is the average mass of the protons plus the neutrons plus the electrons in an element. Don't get confused with this last part right here, because what I need you to understand in a gist, because this is going to take a deeper level a little bit later, but what I need you to understand here is the mass. That's your atomic mass number, is the number of protons plus the neutrons, period. If you can remember that, you'll be able to calculate neutrons when you need to. And I'm going to show you how to do that in just a few minutes. So looking at gold, this is the atomic number, the atomic mass for gold, and this is the atomic number for gold. And in order to calculate the number of neutrons of an element, there's going to be some questions on your EOG and on your classroom test as well as your SMAs. It's going to ask you how many neutrons are in the element, and you're going to have to be able to determine that and calculate that by knowing how to do that. And it's as simple as taking the atomic mass, and I use for my example here carbon. So we're going to take the atomic mass of carbon and we're going to subtract from that the atomic number, and that will give you the number of neutrons and round it to the nearest whole number. So in our example for carbon, our atomic mass is 12.011, and we've got that, and we subtract our atomic number from that, which is 6.0, which will give us 6.011, or round it to the nearest whole number, 6. Okay? So that is the calculation of neutrons. And where are neutrons and protons found? In the nucleus. Electrons are found on the outer shells, and those are the ones that are important for bonding, okay? Also, taking a look at the periodic table. And I'm going to give you a copy of this on Canvas today. This is the one from DPI. And so I would require that you save it in your files so that you have it to come back to digitally, because I'm going to be going over this with you, and you're going to want to put some notes on here, even if they're handwritten or if they're typed with Cami, because remember Cami is our our wonderful little annotation extension. So otherwise, make notes because it's going to be very important. Okay, so going back here, this is an anchor chart that I made for the periodic table. Now, obviously, it is not drawn to scale, but there are some important factors on here. Everything on here is important. So as I'm going over this, you're going to want to take notes on it. So 1869, a Russian chemist named Dmitry Mendeleev organized the elements in the table. The elements going down are called groups or families. Going down, groups or families. When this going across, horizontal rows, these are called periods. Okay? These are called periods. So down is groups or families. Across is called periods. This tells us how many outer electrons are in their outer shell, the order in which they fill their electron cloud, and it also tells us how they like to combine to form other elements, okay? So let's talk about this for just a second. I've got it color-coded, and notice that the yellow represents the non-metals over here. And the majority of the elements on the periodic table are metals. So those are in our orange. And then we have this little staircase is what this is called. And these are ones that are special, and you've got to learn these too. These are called our metalloids, okay? And the metalloids, they are our semiconductors. Semiconductors. And you do need to write this down, guys. Elements that are diagonal between the metals and nonmetals, there are 7 elements that fall into this category. These have properties of both metals and nonmetals, and at certain temperatures they are good conductors, and at other temperatures they are not. These are very important because they're used in things like our cell phones and our computers because they don't ever get really too hot. Why is it important that they not get too hot? Because we know conductors, they get really hot because they conduct heat, right? And our non-conductors, they don't. But our semiconductors, they just don't overheat, guys. So they're important for usage in computer chips and cell phones, okay? So those are important for that reason. Now, our metals, these are what we call ductile. They can be drawn into thin sheets without breaking. They make up most of the table, and they have a metallic shine, or what we call a luster. These are usually solids at room temperature. They are malleable. That is a word you do need to know, meaning that they can be pounded or hammered or pressed into different shapes. They're great conductors of heat and electricity. The next group is called the nonmetals. The nonmetals. And these are located to the right of the staircase, and that's how you need to memorize them, to the right of the staircase. They are groups 14 through 18. Only 18 elements are in this category, usually gases, and they're dull, brittle solids at room temperature. Brittle meaning they can break very easily. They are not shiny. They're not malleable. And they are very poor conductors of heat and electricity. Okay? These are important things for each one of these subgroups that you've got to know. Okay? 2 important groups of nonmetals are your halogens. And they are the noble gases, which is group 18, and these are non-reactive, okay? And we're going to talk more about how they react, okay? These react, these are noble gases. They do not react. What do I mean when I say that? Group 1 or family 1. This group right here is very reactive. I want you to think of this like your family members that are explosive. They have a bad temper. These react with almost everything. Okay? And then the halogens, I want you to think of these as like their first cousins. They still have a temper, kind of like your family members in group 1, but not as bad. So these do react, but not as easily as these. These going to fly off the chain. These are the ones that you don't want to go to family picnics with, okay? These are the ones that you can take to some places, but you can't push them so far. So these are reactive, but these are very reactive, okay? And group 18, guys, this group right here, these are what we call our noble gases. Okay, noble, to me, that word just kind of, to me, strikes royalty. And what do we know about royals? They have somebody that does everything for them. They don't really do a whole lot. Well, guess what? Group 18 going down, they don't do a whole lot either. Our noble gases sit on their, the other word for donkeys, don't say it. Okay, that's how you can remember it. It rhymes with gases. Okay, so they do absolutely nothing, non-reactive. Okay, a chart is organized. You can see the group numbers here, and they go across from 1 to 18. And we're going to talk more about that when I show you the video in just a few minutes. Okay.